Why do some programming languages become exceedingly popular, and others don't?
Many reasons. And calling out individual language you will no doubt attract the rage of devoted followers and detractors. However, it mostly comes down to timing, development cost-effectiveness and opportunity. For instance, Visual Basic appeared around the time Windows 3.1 arrived. Windows 3.1 was maybe the first useful version of the Windows operating system and needed a programming language and an environment that allowed programmers to create sophisticated forms quickly and painlessly. Visual Basic met this need. You could create a window forms using drag and drop from a collection of visual widgets such as buttons, lists, text boxes, labels, etc. The ease with which you could create powerful applications in the new Windows environment was likely the primary reason for Visual Basic's success. One might say that it was also fun to use. The logical successor to Visual Basic was C#. It is easily the most expressive mainstream object-oriented language around today and has benefited from continued development by its owners, aka Microsoft, leading to incorporation of industry-relevant features such as built-in data query access, link, as well as continued improvements to the language's syntax and competencies. However, it remains, at this time, as much a Microsoft-specific language as Objective-C, leading to Swift, is an Apple-specific language. Java and JavaScript, by contrast, are largely platform-independent and have become key languages in the rise of the web. Java is not really regarded as the equal of C# by many, as a language, but C# remains hamstrung by its platform dependence. For now at least. The mediocrity of Java is largely mitigated by an extensive and mature suite of libraries and extensions.
C and C++ are the performance kings, both in terms of raw speed and resource usage. They arrived at a time when hardware performance was relatively poor and consequently we could overlook the intrinsic weaknesses and vulnerabilities in the core language syntax. Yes, we created standardized libraries that went a long way to mitigating the risky nature of the languages. Yes, these remain the languages of choice for performance libraries, device drives, real-time solutions and operating system development. But for high-level applications they've largely been superseded by languages that are considered more cost-effective. C has, to some extent, experienced a resurgence thanks to IoT devices which once again need an efficient, performance-oriented language to get the best from widget-grade processors and hardware. However, we've also seen the arrival of interpreted languages such as Python onto the scene, which has clouded the issue somewhat. Python is primarily a scripting language, but it's very expressive and provides intrinsic handling of complex data types such as lists, tuples, arrays and dictionaries. In common with most scripting languages, it supports an interpreter mode during development which can be very appealing for ad hoc experiments, data science, education and hobbyist-level programming. In a sense, Python fills a niche neglected by most mainstream programming languages. On the other side of the coin is the question of why some languages fade away, often after a period of considerable success. Emergent technologies have often spelt doom for languages and even processor architectures. Upcoming we have technologies such as AI, adaptive programming, where the program tunes itself to the individual user, bio-augmentation, data science-related technologies, virtual environments and massively concurrent solutions. These will create opportunities for a whole new generation of languages and hardware. The reasons for language fade are highly contentious but often come down to a failure to evolve a language and provide support relevant to shifts in architecture, hardware and technologies, or, more simply, because they failed to gain champions to legitimize their continued use, even when the language, for the time, was appealing. Examples include UCSD Pascal, Turbo Pascal, C, Modular 2, Forth and Lisp. Then again, some languages were simply done to death by their principal owners. Visual Age Smalltalk, for instance, was a pioneering product that was massively mismanaged by its erstwhile owner, IBM. Similarly, Fox Pro was murdered by Microsoft. Also, the ability to take some code written by someone else for a different environment or platform and have it work in your environment with minimal straightforward modifications is invaluable. I'm not talking about write once, run anywhere kind of portability, but more intellectual portability. Narrowly focused languages optimized for a specific application space or environment tend not to be as popular. Nobody wants to be learning multiple languages that they don't have to. I can drag out a copy of numerical recipes, or find an implementation in Fortran or C or Python of an algorithm I need, and if it's not too cute, clever coding, have a good chance of getting it to work. Related to that is that languages that are readily available, at low cost, often become popular. Fortran was, and is, popular because it was available on almost every computer in the 60s and 70s. C became popular because it was free to the academic community, and then when microprocessors became common, there were inexpensive C compilers available.